Okay, so we're going to now change polar points to rectangular points and vice versa. Okay, so first thing we're going to do is actually change them into rectangular. So I'm going to graph this. So 60 degrees. So I have turned to the angle 60 degrees and gone up 5. So 1, 2, 3, 4, 5. Okay. So there is my polar point. With a rectangular, we know we have an x and a y. So we have our x coordinate, we have a y coordinate. So lucky for us, we can look at this and know that this has a 5. If we drew this triangle, we have a radius of 60. So really, we just got to do some trig to find our x coordinate and our y coordinate. So this will actually look very familiar because when we did polar coordinate or polar vectors, we actually had the same formula. But let's look at this. So I know to find my x coordinate, I would be doing cosine. So I'd say cosine of 60 equals x over 5. So 5 times cosine of 60 equals x. Now I could type this in my calculator, but 60 is one of those numbers on my unit circle. So we know cosine of 60, sorry, I was using my hands, is 1/2. So we have 5 times 1/2 equals x. So our first point is, or our x coordinate is 5/2. Okay, if we want to find y is opposite over hypotenuse, so this is sine of 60 equals y over 5 times 5 to both sides. 5 times sine of 60 equals y. So then again, 60, we could type in our calculator, get a decimal approximation, but if it's in on our unit circle, let's use that. So we know sine of 60 on the unit circle is square root 3 over 2. So this is 5 times square root 3 over 2 equals y. So I'm going to get 5 square root 3 over 2, and this would be my rectangular coordinate for my, given my polar. So if I was to graph this rectangular on a rectangular Cartesian coordinate plane, it should be in the same spot as this 560 degrees in my polar coordinate plane. Okay, so this should look familiar right here. We found with the polar vectors that this equation was simply x equals r cosine theta and y equals r sine theta. Okay, and it doesn't matter what quadrant you're in or if your radius is negative, this equation is always going to work. Also, these are very important when you get to calculus. So if you're taking calculus next year, these are very important. Okay, so let's do our next one. So we're going to change this into rectangular. So 3 pi fourths. Think about where 3 pi fourths is on our unit circle. Okay, so 3 pi fourths is 135 degrees. So we turn 135 degrees and up 1, 2, 3. Okay, and then we could draw our triangle, and we could actually work it out just like we did here. If we already have this little equation kind of memorized, we don't even need to draw this. So I could go x equals 3 cosine of 3 pi fourths, y equals 3 sine of 3 pi fourths. Okay, so 3 pi fourths, okay, we know that cosine at 3 pi fourths is square root 2 over 2, right? So x equals 3 times square root 2 over 2, okay, and that should be positive. All students, that should be negative. All students take calculus, so that should be negative, which makes sense because it's back here in this quadrant. Our x should be negative. So x equals negative 3 square root 2 over 2. Okay, for sine, we are going to get y equals 3 times, well, we know sine is also square root 2 over 2. All students, S, quadrant 2, sign is positive, square root 2 over 2. So y equals 3 square root 2 over 2. So our rectangular is negative 3 square root 2 over 2, comma 3 square root 2 over 2. Yay. Nice. Not too bad. Sorry, you cannot even see that. So that's our first one, is changing polar into rectangular. Again, these are really nice. They should be kind of already written on your formula sheet. If not, stick them on there. But we really don't need those because we can draw this out and identify our x's and y's and use our trig to find that. Okay, let's look at polar. Okay, we're going to change this to polar form. And I'm trying to see if I have any graph paper that I have not written on. Most of it I have written on, so you could just pretend you can't see anything behind that. Okay, so on a polar coordinate plane, we're going to graph the point negative 3, positive 2. Okay, so we know this was 2, that was negative 3, and what we need to do is we need to find for polar again, that's your radius and your theta, or your angle. So could we find our radius? Yeah, we could. How do we find our radius of a triangle? Well, that's just Pythagorean theorem. So we're going to do the square root of 2 squared plus negative 3 squared. So that's the square root of 4 plus 9, which is the square root of 13. So we've got our first part. We've got the radius is square root 13. Now we just need to find our angle. Well, again, this is just simple trig. We can do tangent because it's given to us. We can use cosine, sine, it doesn't really matter. But because this gives it to me, I'll just use tangent. So, move that off to the side. So I know tangent theta equals opposite, so 2 over adjacent, negative 3. So tangent inverse, wait dear, theta equals tangent inverse of 2, negative 3. Okay, I'm going to make sure that I'm going to do mine in degrees. So I'm going to go to my mode, I'm going to do in degrees. I pulled it out of the parametric from yesterday, it's back to function. I don't think that should mess up anything, only if you're trying to graph, but I'd rather not have it mess anything up, safe than sorry. Okay, so tangent of 2 over negative 3, okay, and theta equals negative 33.69 degrees. Now let's think about this. On this graph, negative 33 is actually somewhere over here. We want in quadrant 2. So tangent only works for quadrant 1 and 4 because of the domain restrictions. So I could just take this and move it 180 degrees, right? It's 180 degrees away because tangent has a period of pi. So if I add 180 degrees, I am going to get theta. So I'm going to add 180 degrees to get 146.3 degrees. So 146.3 degrees. So if we were looking at just generally how to find rectangular to polar, let's see, I'm going to write this right here. So, wobbly. Okay, so from rectangular to polar, okay, we can do r is going to simply equal the square root of x squared plus y squared, the Pythagorean theorem, and theta is going to equal tangent inverse of y over x. But this is only good for first and 4th quadrant. Okay, if you're in the 2nd or 3rd quadrant, what you're going to do is adjust your angle by adding 180 degrees. Okay, if you don't, remember with polar you turn that degree of angles and then you walk forward. So if I turned negative 33 degrees and I walked forward square root 13, I'm going to end up completely different. So this is where I want to be, is this point right here. But if I turned to negative 33 and walked forward, I would be in the wrong spot. I could have turned the negative and walked backwards and got to the right spot. So there's a little bit of kind of creativity here. But generally speaking, we like to just make it a positive degree, and then you don't have to worry about is it forward or is it backwards. Okay, so then let's do D. So again, you don't have to graph it. I honestly like to graph it so I could kind of see where I'm at. Okay, I'm in quadrant 1, so that tells me if I'm in quadrant 1 that my tangent should be just fine. I don't need to worry about adjusting it. Only adjust it if it's in 2nd or 3rd. So I'm going to go my radius equals the square root of 3 squared plus 4 squared. So 9 plus 16. So that is going to give me the square root of 25, which is 5. Okay, so my R is 5. And then I need to find this angle right here. So that's going to be tangent inverse of y over x, so 4 over 3. And that should give me the angle of about 53 degrees. And again, that makes sense. It's 53 degrees. It's within that spot. Okay, so that's your changing polar to rectangular to polar. If you guys have any questions or any that you want me to work out from your assignment, please just email me and I'll be more than happy to post those videos. And I hope you guys have a great day.